So today's lesson is on 3.4 equations and graphs of polynomial functions on pages 136 to 152 in your text. Our curriculum outcomes are the same as the last three lessons. We're looking to demonstrate understanding of polynomials and polynomial functions of a degree greater than 2, limited to polynomials of degree less than or equal to 5, and limited to integral coefficients. Our lesson objectives: we need to learn what multiplicity is and how it affects the shape of a graph. We need to learn how to find where the graph of a function is above or below the x-axis by using the zeros of the function. And we need to use the information from previous lessons in this unit to help us sketch a graph of any polynomial function. So we're going to start our talk off with multiplicity and zero behavior. So recall that when you find the factors of a polynomial, what you're finding is actually called the zeros, or the x-intercepts of that function. The multiplicity of a factor then is how many times it appears in that polynomial. So for example, this function f of x equals x minus 1 times x plus 2 squared times x minus 4 cubed has three factors. It has an x minus 1, which means we have an x-intercept of x equals 1. That has a multiplicity of 1 because there's no exponent up there. The x plus 2 means that we have an x-intercept of x equals negative 2. It has a multiplicity of 2, and at x equals positive 4, it has a multiplicity of 3. And these multiplicities, or these exponents, determine how the graph looks when it crosses the x-axis. And that's what we're going to get into right away here. So the multiplicity affects what the function looks like when it crosses the x-axis. And once again, knowing what a couple basic or normal functions look like will help us when identifying how functions behave with different multiplicities. Okay, so we're in GeoGebra and we're going to take a look at the graphs of three different functions. Now, each of these functions has a different number of factors, but what we do know is that each of these factors has a multiplicity of 1. So we're going to take a look and see if we can find anything in common so we can come up with a conclusion based on what a graph will look like if you have factors with a multiplicity of 1. So our first one is f of x equals x minus 1. Hopefully you will recognize that as a line. And there it is. Straight line. Here's where it crosses the x-axis, and it just plain old crosses the x-axis normally, or what you might think is normal. Our second function, g of x equals x minus 1 and x plus 2, well, x minus 1 means that we have an x-intercept of positive 1, and x plus 2 means we have an x-intercept of negative 2. But in both these cases, again, the graph is just normally crossing the x-axis. Our third one, we have three factors, each with a multiplicity of 1. We have an x-intercept of positive 1, an x-intercept of negative 2, and an x-intercept of positive 3. And here they are, negative 2, 1, and positive 3. And in each case, the graph normally crosses through those 3 points. So I guess what we're saying is, it doesn't matter what the graph or the function looks like, as long as there's a multiplicity of 1, the graph will cross the x-axis normally. So what we're looking at next are factors with an even multiplicity. And so here's our first function is x minus 2 squared. Hopefully you'll recognize that as a parabola and that there's a horizontal shift of 2 units to the right. So let's see. There it is. Horizontal shift of 2 units to the right. And you can see here that this is an x-intercept because the graph is touching it, but it doesn't cross. So we call this tangent to. So it comes down and it touches, but it doesn't cross. Our next function is the g of x function. So we have an x minus 2 squared. So we should have an x-intercept in the same spot at positive 2, but we also have an x plus 3 squared. So we should have an x-intercept at negative 3 as well. Now this graph goes on a long ways up, but as you can see that the function comes down and again it just touches and goes back up in both these cases. So that's with multiplicity of 2. What if it's a multiplicity of 4? So h of x equals x minus 1 to the 4th power. So we know because it's x minus 1 that there should be an x-intercept at positive 1, sorry. And once again, it looks a little bit different because it's a little bit wider, but it still comes down and touches but doesn't cross. So it's still tangent. And our last function, the p of x function, x plus 2 to the power of 4 and x minus 3 to the power of 4 means that we should have two x-intercepts. And by what we've seen, in this case, we should have at -2, it should come down and touch but not cross. And at +3, it should do the same thing. It should touch but not cross. And there it is. So again, this function goes on for a long ways up. Let's see if we can find it. Well, it's a long way up there. We can't quite get to it just by zooming out. But the main thing is that with factors of an even multiplicity, the graph will come down and touch the x-axis, but it won't cross. So it doesn't matter if it's a multiplicity of 2, if it's a multiplicity of 4, if it's a multiplicity of 6 or 8, the graph will always come down to the x-axis, but not cross. Now I keep on saying down, but it's possible for the function to also come up. So if we had a function that looked like this, that's also a possibility. So it'll come up and not cross. So we looked at even multiplicities and we looked at multiplicities of 1. So now we're going to look at factors that have an odd multiplicity that's other than 1. So like 3, 5, 7, etc. So we're going to start with our basic function, which is f of x equals x cubed. So this is what f of x equals x cubed looks like. That's really important to know. If we take a look at another function that also has a multiplicity of 3, this factor has a multiplicity of 3, we know that this should be an x-intercept of +2. And when we look at it, it also crosses the same way. You can also see this as a horizontal shift of 2 units to the right. So what happens if we have two factors and each of them have a multiplicity of 3? Well, we know this should be an x-intercept at +1. This should be an x-intercept at -4. And there's our function. It's coming down at -4. It's still crossing like an x cubed function. So an x cubed function, we say that an x cubed function crosses, but it's also tangent. So here it is getting tangent to the x-axis. Tangent meaning really close to and touching. And then it does cross eventually and pass through the x-axis. So when there's two x-intercepts, each with an odd multiplicity that is other than 1, both these cases, it looks like an x cubed function where it'll be tangent to, but then crossing, and then comes back up, tangent to, and then crossing. So we're now moving into using a sign analysis and intervals, and these things are going to help us sketch graphs of polynomial functions. So what we know already, you should know which quadrant the function will start and finish in, and that's by looking at the leading coefficient and the degree of the function. We should know how the graph crosses the x-axis by looking at the factors in the multiplicity. And the last thing we need to look at is where the function is going to be above the x-axis and below the x-axis. And that will also help us sketch these functions. To do this, we perform what we call a sign analysis. And what we're doing is we're using the sign of a number, so positive or negative, to find out where the function is above the x-axis. So if it's above the x-axis, the function is going to be greater than or equal to 0. I guess not equal to, but greater than 0. And where the function is below the x-axis, and that's going to be where the function is less than 0. Where it's equal to 0 will be the x-intercepts. And in order to do this, we need the factored form, and that's why we learned about the factor theorem and the remainder theorem in previous lessons, so we can factor polynomials. We can take that new factored form and sketch those polynomials. So here's our example. It says use a sign analysis to determine where f of x is below and above the x-axis, and we're going to use that to make a rough sketch of the function. So here is our function. F of x equals x minus 1, x plus 2 squared, and x minus 4 cubed. So a sign analysis means that we're going to take a look at the signs of numbers. So what we're going to do is we start with making it a number line, and we put in what these would be as x-intercepts. So this is just sort of like our x-axis. So we've got a x-intercept of +1, we've got an x-intercept of -2, and we've got an x-intercept of +4. Now, part of the things that we need to know is that there's also intervals here. So the interval is just an interval is a range of numbers. So there's an interval that runs from negative, well, way out to the left, so like -infinity all the way to -2. So everything that's less than -2. there's an interval between -2 and 1, and there's an interval between 1 and 4, and there's an interval from anything to the right of 4, so from 4 all the way to positive infinity. So our sign analysis means that we're going to take a look at where this function is going to be, if it's going to be above the x-axis or if it's going to be below the x-axis. And the sign of the number that we get will determine if it's above or below. So all we're going to do is pick a number from the range, from this interval. So a number that's really close to -2 is -3. So if we find f of -3, we get -3 minus 1. We have -3 plus 2 squared. We get -3 minus 4 cubed. Now the main thing here, we don't really care about the result of these numbers. We just care about the sign. So -3 minus 1 is a negative result. -3 plus 2 is negative, but when we square it, it becomes positive. -3 minus 4 is negative, and when we cube it, it stays negative. So if we have a negative and we multiply it by a positive, and then we multiply it by another negative, we get a positive result. All that means is that when we sketch the function x minus 1 times x plus 2 squared times x minus 4 cubed, what we get is a function where our graph will exist above the x-axis for everything to the left of -2, because that's where it's positive. If you plug in another number to the left of -2, like a -4 or a -5, doesn't matter what number you plug in there, you're going to get another positive result. So we don't have to pick 3 or 4 different numbers, we're just going to pick one. All right, our next interval is between -2 and +1. So we're going to find out what happens when we plug in a number from between -2 and +1. Well, I'm going to choose 0 because that's in between -2 and 1. So I get 0 minus 1, I get 0 plus 2 squared, and I get 0 minus 4 cubed. Again, not caring about the result, just the sign. 0 minus 1 is a negative answer. That happens to be -1. 0 plus 2, and I square that, that's going to be positive. And 0 minus 4, when I cube that, that's going to be negative. So I get a negative times a positive times a negative, makes that another positive result. Likewise, if I find f of 3, which lies between 1 and 4, I get 3 minus 1, 3 plus 2 squared, and 3 minus 4 cubed. 3 minus 1 is positive. 3 plus 2, and then squaring it is positive. 3 minus 4, though, is negative, and when I cube that, it stays negative. So a positive times a negative is negative. And finally, picking a number that is greater than 4. So like 5, I plug it into my function. I get 5 minus 1. I get 5 plus 2 squared, and I get 5 minus 4 cubed. So 5 minus 1 is a positive number. 5 plus 2 is a positive number. I square it, it stays positive. 5 minus 4 is a positive number. I cube it, it stays positive. So my final result here is a positive number. So we've determined where this graph is now above the x-axis, that's where it's positive, and where it's below the x-axis. Now we know that these factors all correspond with x-intercept. So we've got an x-intercept at -2. We've got a x-intercept at +1. And we've got an x-intercept at +4. Now remember that these multiplicities also mean something. A multiplicity of 1 means that it crosses. A multiplicity of 2 means that it looks sort of like a parabola where it touches the x-axis but doesn't actually cross it. And a multiplicity of 3 means that it is tangent to the x-axis but then also crosses it. So we're going to keep that in mind while we're sketching this function and while we take a look at where it's above and below the x-axis. So there's lots of little things to help us sketch this function. So on the left-hand side of -2, it is above the x-axis, which means it has to be above. When it hits -2, it's an x-intercept. So we know it at least touches the x-axis, but it stays positive, which means it comes down and goes back up. And that corresponds with what we know with multiplicities. With the multiplicity of 2, or an even multiplicity, it touches but doesn't cross. Now at our x-intercept of +1, it goes from being above the x-axis where it's positive to below the x-axis where it's negative. Multiplicity here of 1 means that it just crosses normally. Finally, to the right of 4 means that it has to go above the x-axis again, so it's going to have to cross at 4, and the multiplicity of 3 means that it crosses like an x-cubed graph, so kind of tangent and then comes back up. And there's our rough sketch of this function. F of x equals x minus 1 times x plus 2 squared times x minus 4 cubed. Now, one more important point to note is that there's always going to be a y-intercept. We need to be able to find that y-intercept. And finding that y-intercept is easy because we just plug in an x value of 0. We've done that for the last couple of years. So we plug in 0 minus 1, 0 plus 2 squared, and 0 minus 4 cubed. So when we're done that, we get -1, we get a +4, and we get a -64. And so in the end, we get -256. +256, sorry. So that means this point right here where we've sketched it, that would be at a value of 0, 256. So in summary, the multiplicity of a factor determines how the function crosses the x-axis at that point. And the key thing is how. So the multiplicity again is the exponent on those factors, and that'll help you determine how it crosses the x-axis. So a little table I've made for you here. If the multiplicity is even, we said we know that it crosses like a parabola. So it could look like this, coming down and crossing, or it could be coming up and crossing. It totally depends on that sign analysis that we do. If it has a multiplicity of 1, it crosses like a line, so it's going to cross something like this, or maybe something like that. And if it's odd but greater than 1, so that multiplicity has to be odd but greater than 1, like 3, 5, 7, it's going to cross like an x cubed function. So something like that. Or something like this. So this is what we call tangent. This is just crossing. And this would be both. It's tangent and then crossing. So that's just a summary of multiplicity. A sign analysis can tell you where your function is going to be above or below the x-axis. And that sign analysis is pretty important when you have to sketch functions. And you need your function in factored form in order to do this, which means you need to know synthetic division and you need to know the remainder or / factor theorem. So a lot of little things. We'll take some time in class to go over them again if you need, but the important thing is that all these things connect. So everything from 3.1 to 3.4 is important because they all connect together. Your assignment's on page 147 to 152. Good luck, and I'll see you in class.